Good afternoon, everybody. We have a very, very interesting masterclass today. This is on artificial intelligence and technology. Uh, we have Professor Guha with us today. Uh, I really, really welcome you, sir, on this session. He has really come today on a very short notice. Let me introduce him. He's a member of the faculty of SP Jain School of Global Management and director of the master's program in artificial intelligence in business. Over the last 3 decades, he has taught and carried out research in the field of artificial intelligence at leading US and Indian universities. And he has been a consultant for major and minor multinational corporations and banks and government across the world. Professor Guha has a bachelor's degree from IIT Kanpur and a PhD from Columbia University. Welcome, sir, on the session. And without any further ado, I hand over the session to you.
Thank you. And it's IIT Kharagpur. My KGP buddies will never forgive me if I didn't correct you. Okay, thank you very much for that wonderful introduction, Ms. Chutsi. Um, Today, we are going to be talking about artificial intelligence and allied technologies. Can you hear me all right?
Yes, we can hear you all right. So I'll be on the backstage and I'll leave the
Okay,
screen for you. Thanks.
and I will start sharing my screen soon, but let me give you a preview of what we are going to do. We are going to start with a basic definition of what artificial intelligence is, and talk about some aspects of that definition, how it relates to the real world, how it relates to various subtopics. After that, we're going to go into a demonstration of one of the most exciting developments in artificial intelligence in the last year, and that is uh, the AI tool called GPT-3, which was developed by DeepMind, by Elon Musk's company. And we are going to give you a demo of what it can do, one particular thing it can do. After that, we are going to go and talk about a different, very different kind of application. Once this is done, then we're going to talk about how to think about AI and its effects upon the world, what it means for each one of us in terms of how we construct our careers, our jobs, and our relationship with this new technology. And we'll end up with some ideas about where we could find more information and more training about this exciting new technology. So I'll start with I'll start with this definition, and we're going to talk about this definition in more detail once we understand the basic idea of it. The task of artificial intelligence is to design agents that can perceive the environment and carry out a plan of action to reach a goal. Let's talk about each one of these uh, phrases, if you will, that are included in this definition. First is design. The task of artificial intelligence and artificial intelligence engineers is to design things. It also is to run things, but the run part usually is taken over by other people, sometimes software people. So the core task of AI at this point of time is to design things rather than to run things. But of course, the running is also part of the artificial intelligence workflow. And what is it that AI engineers design? They design agents. Now, what is an agent? An agent is an entity that could be a human, could be an animal, or could be a artificial entity like a robot, or even a piece of code that has some agency, that can do things, that can think about things, do things, plan things, and so on. So, what do these agents do? They can perceive the environment, they receive signals from the environment, and these signals can be of various kinds. This could be a camera that's capturing vision, This could be a mic that's capturing audio. This could be a software bot on a website that's receiving comments from the users. So these are all signals coming from the environment. They could be quite restricted, such as that of a chatbot, which only can listen to, or uh, read texts that come through that website. Or it could be much more general, like a humanoid robot, which has to uh, process visual, auditory, and other information. And based on these signals from the environment, the agents try to reach a goal. And that's fundamental to the conception of AI as we know it now, that all these agents have goals. Of course, humans and animals have goals too. Most animals have, very limited goals to eat, sleep, and so on. And humans have more complex goals. Nevertheless, we do have goals. And so all these agents have goals. They're either set for the agent from the outside, or some of the goals may be defined internally. And once the goal is set and the data from the environment is streaming in, based on the data and the goal, the agent formulates a plan of action and carries it out. So, for instance, take a robot that's a vacuum cleaning robot. Its job is to clean a set of rooms in an office building. So its goal is to go into each office and collect the trash that is in a trash can, empty it into a repository, and take it out and dump it into some predetermined site. Its goal is to keep the trash bins as empty as possible, and at the same time not to make too many trips. So these are conflicting goals. It has to resolve these two goals and find a plan of action that doesn't require too many trips and at the same time keeps the offices reasonably clean. And this plan of action then must be put into a practice, and the robot must maneuver itself to each room, maneuver it to the where the trash can is kept, either remove it and empty it, or if it's not very full, maybe leave it there because its own dumping site is too full, or and so on and so forth. So this is essentially what an artificial intelligence does. It has it designs an agent that takes in signals from the environment and carries out a plan of action to reach some predetermined goal or some internally defined goal. And its subfields are things like vision, and here we're talking about all vision, machine vision related tasks such as face recognition, video understanding, generating captions for pictures, and generating new faces. That's very big now. The idea called deep fake, where you can generate a face that never existed. And these are all computer vision tasks. There are robotics tasks, language and speech, speech generation, speech understanding, and also text generation and text understanding. Learning, which turns out to be very important in all of these tasks and is becoming a component of all the other tasks. And planning, which again is a component of many of these tasks. So that is what artificial intelligence is all about. Now, next we are going to talk about a special type of artificial intelligence, and this is called GPT-3. And GPT-3 is the current version. GPT-4 is already on the anvil and will reach us sometime in 2022. It is essentially what is called a very large neural network that takes billions and trillions of pieces of data and digests them. And the essential task which GPT-3 has been designed for is to generate text and speech. However, it turns out that many things can be considered text. For instance, writing software can be considered a text generation task. In some cases, even some vision tasks can be reformulated as text generation text. So some uses that GPT-3 has found are to help companies understand their customers by analyzing the customer feedback, to generate new stories that are interactive and that are voiced by virtual beings. Semantic search, meaning, try to understand it. When you do a Google search, it's mainly keyword search, but both Google and GPT-3 based methods are now going to go to semantic search, where the search tries to understand uh, what's in the query, what the query is trying to say. Fourth would be generate machine learning model, the code for the machine learning model, given just the data set and what you want out of it. So given a data set and given what information or what structure you're trying to extract from it, it will write the code. Uh, then you can build a website that is generate both HTML and CSS code. Once you describe what the website should be like in simple English sentences, it can generate a song, a guitar tab from a song title and an artist, and this song title and artist can be fictional, and it can you can use GPT-3 to construct a personal assistant that interacts with members of a team and manages their work together. So these are all examples of tasks that general intelligence GPT-3 can do. What we will do now is we will go to a site that lets you access GPT-3 and lets you, the way GPT-3 works is that you put in a prompt. So you write 2 lines of a blog. Say you want to generate a blog, you write 2 lines of it, and the GPT-3 generates the rest of it. So what we are going to see now is a an application where we go to uh, GPT-3 and it generates a, a song for us. We give it a line and it generates a song lyric for us. So we have one already. I used snippets of old songs, and the first one I used was "I Want to Hold Your Hand," which is an old Beatles song from the 1960s, and you can generated this lyric. Let's try something else. Let's try just let's try another old song. It's a very old song from the 1940s, I think, and it's a jazz song. So instead of jazz, let's generate a death metal song from. So this is what it generated. Singing "Pop in the Trees" has died out, the walls are cold and they got me down. So icicle in my gut might make this easier. Lights on, but nobody's home. Feel the cold through my skin, it feels good. Who'd care if I get frostbite on every limb? Sounds appropriately death metal, I think. Uh, let's try something else. Let's try a more recent lyric. I hope you recognize that's Beyonce. And instead of death metal, we will try to generate, let's say, let's try reggae. Well, they spelled it wrong, but I think they mean reggae. If you liked it, then you should have put a ring on it. And they repeat it 3 times because if you liked it, then you should have put a ring on. Not very impressive, but at least it generated something. Let's try something completely different. Let's try a French. French song. This is a very famous song that those of you who have seen Inception will recognize that this was the song in the background. And let's try to generate a gospel song out of it. Takes more time, as you can see, because it's not in English, and it couldn't do it because it's not in English, I guess. So let's try and put it through something else. Let's try song that most of us would know, and let's see what it does with that. Again, it has difficulty because we're given a non-English, and it couldn't do it. Actually, I have an old one that I did earlier, and it was able to do that. So I'll go through them now. Some that I have generated already, and I will show you what it did with those. Not sure what the problem is. Can't get it to share. Okay. So I will show you the one that it did earlier with Sare Jahan Se Acha. That's what it did with Sare Jahan Se Acha Hindustan Hamara. And it's, I don't know enough Hindi to tell you whether it's gibberish, but some of it looks like gibberish, but some of it looks like it is actually a Hindi song. Of course, it put in two English lines in it, which sounds very strange. Who dreams of a Hindustan? We dream of a country under the moon. Whatever that might mean. But anyway, it did something that makes at least some sense. So this is one of the most exciting developments in artificial intelligence recent times, where you can give a short input to the AI and receive a song, a story. You can give it uh, a, a piece of email, and it will rewrite the email to make it sound more pleasant or more unpleasant, whichever way you want it. And various uses have been already put for it. And GPT 3.4 is going to come out this year. I mean, not this year, but 2022, and that's going to be even fancier than GPT 3. So these are some of the examples that one of the most interesting uses of GPT-3 is. Next, I'm going to show you a video that shows quite different. What we saw was interesting and a bit sunny, if you will, something that gives us hope for the future, maybe. What we are showing now, what I'm going to show now, is kind of more murky and certainly much more controversial, and maybe even not entirely a good idea.
We have something much bigger. Your kids probably have one of these, right? Not quite. Hell of a pilot? No. That skill is all AI. It's flying itself. Its processor can react 100 times faster than a human. stochastic motion is an anti-sniper feature. Just like any mobile device these days, it has cameras and sensors, and just like your phones and social media apps, it does facial recognition. Inside here is 3 grams of sheet explosive. This is how it works. Did you see that? That little bag is enough to penetrate the skull and destroy the contents. That is an airstrike of surgical precision. It's one of a range of products. Trained as a team, they can penetrate buildings, cars, trains, evade people, bullets, pretty much any countermeasure. They cannot be stopped. Now, I said this was big. Why? Because we are thinking big. Watch. A $25 million order now buys this. Enough to kill half a city. The bad half. Nuclear is obsolete. Take out your entire enemy, virtually risk-free. Just characterize him, release the swarm, and rest easy.
Okay, so that's
We have something.
some of the two of examples of application of AI. One very hopeful that can do amazing things. The other, which is probably yet to come, but very scary in terms of what it will be able to do. And both of them fall under the general rubric of what we defined earlier, that it is an agent that can perceive the environment and take a series of actions according to a plan in order to reach a goal. So the goal may be as simple and non-controversial as writing song lyrics or songs, song notation, or it could be as controversial and scary as hunting down people and killing them. There is a huge controversy at this point in the AI circles as to whether the enormous potential of AI should be regulated because it has enormous potential for both good and for evil. And this question is not yet settled. And there are arguments on both sides of it. And I gave you two examples in order to make clear to you that we need to consider the ethics of AI. This is a very important issue in today's world, and see how it will develop and how it will either benefit or harm society. Now we take a sidestep, if you will, and talk about briefly how to think about what kind of changes AI is going to bring. In order to do that, it's important to think of two parts of any process. any process that requires a lot of analysis. One part of it is pattern recognition, trying to find patterns in data and use them to predict either the future or to detect what is already happened. So, for instance, some very well known applications of AI depend on identification of a pattern. For instance, in finance and banking, people want to know whether a loan will default, whether it will default in the next 3 months. In HR, whenever we, in human resources, whenever we hire someone, we would like to know some estimate of how well that person is likely to perform. In marketing, we want to find whether a customer that walks in the door, what he's willing to buy, what he's likely to buy, whether he's going to buy anything at all, and so on. In production, one major question that is always being asked is whether an equipment will fail within the next day, next week, next month, and so on. And then detecting a pattern that's already present, for instance, whether a patient has a certain disease, whether a transaction is fraudulent, whether, in forensics, to scan a room and find out if somebody there is planning some kind of a criminal act, whether they're carrying a weapon and things like that. So these are all pattern recognition tasks, and as we will see, pattern recognition depends on looking for hidden patterns in a very big and high dimensional data. In most cases, AI is going to be better than human at this pattern recognition task. Already it is better at various pattern recognition tasks, and is going to get better and better using current technology and additions to current technology that we are sure to find. So pattern recognition is something that, like calculation, that computers are going to be better at. Computers and calculators are already much better than humans at arithmetic and in some algebraic manipulations also. Uh, Therefore, it is not surprising that when it comes to crunching large amounts of data and finding patterns in it, computers, that is to say AI, better at it. But there is another aspect to most of these processes, and that is judgment. Judgment is the act of making complex decisions using pattern recognition and prediction as an input. So you enumerate all possible actions, you estimate, what each action will bring, and then you take the outcome that is likely to bring the best reward. This is the application of judgment. You judge, given a foggy, uncertain situation, what you have to do is to think about what actions you could take and what each action will bring, most likely outcome of each action, and then take the action that is either the best in terms of reward or best in terms of risk, or perhaps best in terms of reward as a function of risk, uh, best reward given that risk is not too high, highest reward so that lowest risk with a certain amount of risk reward, and so on. So judgment is something in most cases that follows intuition. It cannot be calculated. If it could be calculated, then AI and other quantitative methods would probably do well at it. But in many real life situations, judgment requires a human in the loop. And this is the essential dichotomy of what is happening in either human tasks being replaced by AI or AI working in tandem with people to achieve outcomes. And this is going to be true for at least the foreseeable future, maybe in the next 2 decades, 3 decades, that humans and AI are going to fill complementary roles where humans are still going to be in the loop to provide judgment where it is needed. And AI is going to provide pattern recognition and prediction to make this judgment easier. In some cases, the judgment task itself can be reduced to pattern recognition. For instance, used to be, give you another famous example. This is the movie Moneyball, which some people might have seen. This is the movie where a baseball manager decides that data crunching is a better way to find good players than judgment, which used to be the way scouts used to go out and use their judgment based on experience to identify the best players. And somebody comes and shows that that is not the best way to do it. The best way to do it is to analyze a lot of data and find patterns in it. And that does a better job than even the best scouts. So some judgment tasks are being replaced by pattern recognition tasks, and this is a process that will continue. However, there are more complex judgment tasks that still cannot be reduced to pattern recognition. So this is the map of what we usually do. There is data. Based on data, we predict what will lead to what, but that is not enough to tell us which action to take. So we apply judgment using prediction to take an action, and that results in some outcome. And there is a feedback as to whether your action was the correct one or not. And in light of the outcome and in light of the feedback about the outcome, we change our prediction, our judgment. And this is the process by which uh, complicated tasks, complex tasks must be performed. Here, the gathering of data and prediction using pattern recognition are AI tasks. Judgment, on the other hand, will be a human task, and the two together will lead to the action uh, that will drive the process. And as you can see, this imagines what is called a human machine cooperative system, where there is a AI taking part of the decision, part of the data crunching, or most of the data crunching actually, and the people will provide the intuitive judgments which AI is still not able to make. So we know already that AI is better than humans at most prediction tasks or pattern recognition tasks, such as playing chess or playing Go, reading X-rays, recognizing faces, you know, diagnosing disease, credit analysis, all of these things. Uh, Many of them used to be judgment tasks. For instance, there used to be physicians who would jump to conclusion based on diagnosis. In the old days, based on just feeling the pulse. But most diagnosis is done through tests now, and that means that AI tends to be better at it. Same thing with credit analysis. Credit analysis may involve judgment of character, which of course AI still cannot do. But if it's based on documents and numbers and figures, then AI is better at it. And cheaper prediction, prediction is getting cheaper and cheaper, and there will be more and more AI jobs. And judgment jobs, for instance, that make the distinction. Diagnosis is a prediction task. It's based on symptoms. It's based on test results, and based on a whole body of knowledge about how symptoms and test results map to specific diagnoses. But after diagnosis comes the question of what are the different treatment options, and to actually administer that option, that which is to say, if it's a serious illness, the doctor must work with the patient to make sure that the patient follows the treatment regimen and stays with it, and maybe accelerate or decelerate the rate of treatment in tandem with the performance by the patient. So this task still cannot be done by AI, because it requires understanding the psychology of a patient, requires empathy, it requires understanding the patient's context, familial and otherwise. And those are tasks that AI still are very far away from achieving, and require judgment that only a trained physician can bring to it. Similarly, when hiring, you could have a predicted performance based on resumes and perhaps even interviews, but that's only partial. When you form teams and when you manage teams, AI can help. As we saw, GPT-3 based tools can help, but ultimately it's up to the leader to form a team and to lead that team so that it performs best. In sales, list formation, given a large list, to whittle it down to the most likely ones and so on. These are prediction tasks that are already done by AI. But if you're talking about a complex big ticket sale, say an infrastructure project that has to be sold to the government, for instance, or a major development project that needs to be put through and sold to a community, let's say, that is something that AI cannot do. It can crunch numbers, it can tell you who to go to and so on, but the actual task of persuading a committee or some group to say yes to a large project, whether it's in a corporate setting or a government setting or a community setting, is going to be a judgment task that only people can do. So, the question to ask when you're thinking of a career in the AI economy, there is, of course, the technical issue of learning, the basic AI tools. In some sense, that's the easier task. So the question you should ask is, which tasks, which jobs are going to fall to AI? It used to be thought that bankers who give out loans perform a very useful function, and it's a judgment task. More and more, it's purely a numerical pattern recognition task that AI can do. Certain jobs, entire jobs and job categories, for instance, radiologists are in danger of being completely replaced by AI. It's still not
Wow.
time for that yet. Yes, somebody had a question.
Yeah, it's amazing to hear to what you have just now told us. AI is the future. It looks like completely our lives would be in the future, good or bad. We have to decide that. But AI is the future. Since we are running short of time, I had a few I wanted to ask
Yeah,
before we end
sure.
the session. Yeah.
Yeah, sure.
The first question Joyce is asking is there a way that AI can recognize deep fake?
Recognize what? Sorry.
I think she's trying to say deep
Deep
fake.
Deepfake, yes, that has aroused a lot of controversy where you can fake faces, you can fake what these faces take. There was a famous example of fake speech made by former President Barack Obama. uh,
Hmm.
the work is on in terms of how in it's an arms race, if you will. Some AI researchers are trying to find ways to detect deep fakes, where the deep fake people are making their deep fakes more authentic, so that it's very difficult to determine. So it's kind of an arms race, if you will.
Sure. The other question that one of our students has asked is, do you necessarily require an engineering or a maths degree to study AI?
No, and let me put out the next slide to confirm that. This is a program that we run at SP Jain. It's a master's degree in AI in business. It's a
Hmm.
2-year master's course, which is a combination of AI and management. And we have of the class that is going to start next month, approximately 30%, one third, are people who do not have engineering or science degrees. So it
Right.
is very much possible for someone with commerce or even an arts background to study this. However, they must fulfill two conditions. One is that they must have analytical ability to think analytically and clearly, and second is they must have at least some quantitative skills.
Sure.
Somebody who has never done any math, even in high school, is probably
Hmm.
going to find it very difficult.
The other question is, how is machine learning related to AI?
I didn't go into that because that's a question that is often asked. Machine learning is really part of AI. It's one part of AI. In the past, it used to be considered one fairly big, but not bigger than anything else. However, in the last decade, what has turned out that machine learning is becoming kind of the bedrock, the foundation for a lot of other tasks in AI. For instance, computer vision, which used to be its own field, had its own algorithms and methodology, now is done entirely by machine learning. All computer vision people are applying machine learning and deep learning to vision tasks.
Right.
Same way with language understanding used to be its own field. Now it's done by deep learning. Like GPT-3 is all deep learning. So machine learning is becoming, it's still a subset of AI. There are still parts of AI that are not machine learning, but it's becoming a bigger and bigger part of AI, if you will. So
Sure,
if
sure.
if machine learning was like 20% of AI, 10 years ago, it's maybe 60% of AI now.
Thank you. I think we'll take the last question because we are running short of time. I think is the most important question is, will AI take all our jobs? Will we be combating with AI eventually in the next 2 decades?
Well,
Where does
that's what,
AI lead us?
yeah, that's what I wanted to highlight in the last section that I did, is that, there are two kinds of jobs. One job is purely prediction, pattern recognition type jobs.
Sure,
Those jobs are going to go away. It's going to be all AI. And the other kind of job is judgment, which requires a lot of judgment. And so it's will be a long time before we see an AI running the treatment for a cancer patient. you
sure,
know it can diagnose cancer maybe, but to actually treat a cancer patient, lead them through the regimen and the therapies, requires a doctor with, you know with empathy, with, knowledge of social context and so on. And surprisingly, the jobs that are most unlikely to fall to AI are not all high end jobs. For instance, and I forget the name, it's called it's some paradox in AI. For instance, the job of a gardener is still very far from being replaced. There are no gardening AIs that are up to the task yet. So let's not forget that there are lots of jobs that are not considered high end jobs, but are unlikely to be replaced by AI anytime soon.
sure. Thank you so much, Professor Guha, for your time and such a nice talk today. I think our students enjoyed. There were quite a few of them, and a lot of parents and working professionals who joined us today. Thank you so much for your time, and we look forward to seeing you soon in one of these sessions again.
I sure hope so. Then, thank you very much for inviting me. I enjoyed, uh, you know, this interaction, and I hope your people can, if they reach out to me, I am available for sessions in the future.
Perfect. We will be in touch. Thank you so much, sir.
Thank you. Bye now.